Hey everybody, my name is Pranjal and I'm an SRE program manager at Google. And I'm speaking to you from my home in San Francisco, California. It's about 11:08 a.m. here. So after keynoting in DevOps Days Portugal last year, where I spoke about blameless postmortem culture, I'm pretty excited to come back and collaborate with familiar faces present at DevOps Lisbon. The topic for today's talk is engineering reliable mobile applications. So here's a little bit about myself. I'll go through this really quickly. I've been at Google for about 4 years, in the San Francisco Bay Area for about 10 plus years. I currently spend majority of my time working on client infrastructure SRE, and I've just started to work and spend a little bit of time on Firebase SRE. I've also had the opportunity to work on some Gmail spam abuse SRE projects last year. I've co-authored the Blameless Postmortem Culture chapter in the Site Reliability Workbook. And today's talk is also captured in a publication called Engineering Reliable Mobile Applications, and both of these are available on the SRE website for free. In terms of my career, I have an electrical engineering degree. The theoretical knowledge I've never used ever in my career. And then before joining Google, I was in sort of a jack of all trades sort of a role, and I juggled multiple hats at Batalia. They develop innovation management software for enterprise. I've also spent some time learning and teaching some Bollywood dancing. And as far as my current obsession, it's my 6-month-old golden retriever puppy. His name is Teddy. So in case you hear some barking in the background, it's probably him. And I also love exploring cuisines and traveling. And it's such a bummer that I couldn't visit Portugal this year. Last year when I came, it has been one of my most favorite solo travel experience, and I keep recommending it to people again and again. So in terms of today's agenda, I'll briefly cover the basics of traditional SRE, just one slide, and then compare and contrast it with what it means to be SRE for mobile. I'll go deeper and talk about several distinct challenges, such as scale, monitoring, control, and change management. Then I'll go into high-level strategies for developing resilient native mobile applications. This will be followed by 3 case studies: actual outages that happened at Google with our apps, and then what we learned. And towards the end, I'll summarize overall key takeaways, some things to keep in mind to evaluate the reliability of your current and future mobile applications. So quick brief of SRE. I assume most of you already know this, but just to set some context, especially for newer folks, SRE is a specialized job function that focuses on the reliability and maintainability of large systems. It's also a mindset. The approach is that of constructive pessimism. In terms of people, while SRE is a distinct job role, they partner closely and collaboratively with our partner product dev teams throughout the product lifecycle. In terms of day-to-day work, of course, the primary responsibility is to ensure health of the dedicated services in terms of availability, latency, efficiency, emergency response, change management, monitoring, capacity planning, etc. And we're also encouraged to work on horizontal projects. That is, if one piece of infrastructure can solve similar use cases for many other teams, that's also a good thing. Now, to segue into mobile, when we talk about availability, it is commonly assumed that we are only talking about server-side availability. A lot of SLAs have also traditionally been bound by server-side availability, for example, 2 or 3 nines of server uptime. But the problem with relying only on server-side reliability as an indicator of service health is that users perceive the reliability of a service through the devices in their hands. We've seen a number of production incidents in which server-side instrumentation taken by itself would have shown no trouble, but where a view inclusive of the user experience reflected end-user problems. I can give you a few examples. This has happened with me, might have happened with you also. So your service stack is successfully returning what it thinks are perfectly valid responses, but users of your app are seeing blank screens. Or sometimes users open the Maps app in a new city for the first time. They would suddenly see a crash before the servers received any requests at all. After your application receives an update, although nothing has really visibly changed, users sometimes experience significantly worse battery life from their devices than before. These are all issues that cannot be detected by just monitoring our servers and data centers. Now we can compare a mobile application to a distributed system that has billions of machines. The scale is just one of the many unique challenges of the mobile world. Things that we take for granted in the server world today become very complicated to accomplish for mobile, if not impossible for native mobile applications. So following slides will present to you just some of the basic challenges. So challenge number one, scale. In terms of scale, there are billions of devices with thousands of device models, with hundreds of apps running on each one of them, with each app maybe has its own multiple versions. It becomes more difficult to accurately attribute degrading UX to unreliable network connections, service unreliability, or other external factors. All of this combined makes for a very complex ecosystem. Challenge number two, monitoring. Unfortunately, we need to tolerate potential inconsistency in the mobile world because we're relying on a piece of hardware that's beyond our control. There's very little we can do when an app is in a state in which it cannot send information back to you. Now, in this diverse and complex ecosystem, the task of monitoring every single metric has many possible dimensions with many possible values. It's infeasible to monitor every combination independently. And then we also must consider the effect of logging and monitoring on the end user, given that they pay the price of resource usage. Battery and network are just two of those examples. Challenge number three, control. Now on servers, we can change binaries and update configs on demand. In the mobile world, this power lies with the user. In the case of native apps, after an update is available to users, we cannot force a user to download a new binary or config. Users may sometimes consider upgrades to be an indication of poor quality software and assume that all upgrades are just bug fixes. It's also important to remember that upgrades can have a tangible cost, for example, metered network usage to the end user. On-device storage might also be constrained, and data connection might be sparse or non-existent. Challenge number four, change management. Now, if there's a bad change, one's immediate response is to roll it back. We can quickly roll back servers, and we know that users will no longer be on the bad version after the rollback is complete. On the other hand, it's almost impossible to roll back a binary for a native mobile application on Android or iOS. Instead, the current standard is to roll forward and hope that the affected users will upgrade to the newest version. Now, considering the scale and lack of control in the mobile environment, managing changes in a safe and reliable manner is one of probably the most critical pieces of managing reliable mobile applications. Now, in this next section, I'll talk about some concepts that are not foreign to us as DevOps folks or SREs, but I'll put them in the context of mobile and discuss some strategies to tackle them. I'll spend some time on this slide. Now, availability is one of the most important measures of reliability. In fact, we set SLOs, or service level objectives, with the goal of being available for a certain number of nines. For example, 99.9% available. SLOs are an important tool for SREs to make data-driven decisions about reliability. But first, we need to define what it means for a mobile application to be available. To better understand this, let's take a look at what an availability could look like. Now think of a time when one or multiple of these could have happened with you. For example, you tapped an app icon and the app was about to load when it immediately just disappeared. Has happened with me for sure. Or a message displayed suddenly saying application has stopped or application not responding. Also happened with me. Or you tapped a button and the app made no sign of responding to your tap. When you tried again, you got the same response. Or let's say you searched for something. Either an empty screen appeared or a screen with older results appeared and then you had to manually refresh. Or You waited for something to load and eventually abandoned it or just clicked the back button because it was way too frustrating. So all of these are examples of an application being effectively unavailable to you. You, the user, interacted with the application and it did not perform in a way that you expected. One way to think about mobile application reliability is its availability or its ability to be available, servicing interactions consistently relative to the user's expectations. Now, users are constantly interacting with their mobile apps. And to understand how available these apps are, we need on-device, client-side telemetry to measure and gain visibility. Now, you know that if you cannot measure it, you cannot improve it. But of course, privacy and security are topmost concerns, so we also need to keep those in mind when developing a more monitoring strategy. Now, one example of evaluating availability is gathering crash reports. So when an app is crashing, that's a clear signal of possible unavailability. A user's experience might be interrupted with a crash dialog, the application may just suddenly close, or the user might be prompted to report a bug. Crashes can occur for a number of reasons, but whatever the reason, it's critical to monitor and triage these issues right away. There are some tools, I'm not too familiar with it, but there are some crash reporting solutions such as Firebase Crashalytics that can help collect data on crashes, cluster them based on struct base, and alert you of anomalies. On a wide enough install base, you can find crashes that occur only on a particular app or platform versions, or it could be from a particular location or a certain device model, according to your combination of factors. All right, in terms of real-time monitoring, who doesn't love real-time metrics? Now, the faster one is able to alert and recognize a problem, the faster one can begin investigating. Real-time metrics also help us see the results of our fixes and get feedback on production changes faster. Now, most incidents have a minimum resolution time that is driven more by humans organizing themselves around problems and determining how to fix them. For mobile, this resolution time is also affected by how fast we can push the fix to our users' devices. Now, most mobile experimentation at Google is polling oriented, with devices updating themselves during opportune times of battery and bandwidth conservation. This means that even after submitting a fix, it might be several hours before client-side metrics can be expected to normalize. Now, telemetry for widely deployed apps is constantly arriving, so despite this latency, telemetry from some devices that may have picked up the fix will shortly arrive afterward. Is the audio okay now?
Yes, it is.
Yeah? Okay.
Thank you.
Sounds good. I'll continue. Okay. So one approach to design metrics derived from device telemetry is to include configuration state as dimension. You can then constrain your view of the error metrics to only the devices that are using your fix. This becomes easier if client changes are being rolled out through launch experiments, and you can look at the experiment population and the experiment ID to monitor the effects of your change. Now, when developing an app, we have the luxury of opening a debug console and looking at fine-grained log statements to inspect app execution and state. However, when it's deployed to an end user's device, we have visibility into only what we have chosen to measure and transport back to us. So measuring counts of attempts, maybe errors, states, or timers in the code, particularly around key entry or exit points or business logic, could provide indication of an app's usage and current functioning. Another good idea is to run UI test probes to monitor critical user journeys. This would entail launching a current version of the binary on a real or emulated device, inputting actions as a user would, and asserting that certain properties hold true throughout the test. Now, performance and efficiency. The resource that enables your phone to be mobile in the first place is battery, making it one of the most valuable resources of a mobile device. Then there are other precious shared resources such as CPU, memory, storage, network, etc. No application wants to misuse any of these resources and garner negative reviews. So efficiency is particularly important on lower end devices and markets where internet or data usage is high cost. Unfortunately, the platform as a whole suffers when the shared resources are misused, and increasingly the platform needs to place restrictions to ensure common standards. One example is maybe Android Vitals that can help attribute problems in a particular app. Sometimes we've blocked apps from releasing for battery regressions as low as 0.1% because of the negative use effect on user happiness. Any expected regressions need to be released only after careful considerations of the trade-offs vis-a-vis the benefits a feature could provide. Now, change management. This will be a long slide, so bear with me. I'm going to spend a little bit longer on this slide because there's lots to talk about. Now, many of the best practices while releasing client applications are based on the similar SRE principles that we already know of. The change management is one of the most critical pieces of mobile ecosystem because a single new faulty version can erode user trust, and they may decide to never install or upgrade your app again. Rollbacks in the mobile world are near impossible, and problems found in production are irrecoverable, which again makes proper change management extremely important. So the first strategy could be a staged rollout. This simply means gradually increasing the number of users an update is released to. This also allows you to gather feedback on production changes gradually instead of hurting all your users at once. So one thing to keep in mind here is internal testing, and testing on developer devices does not provide a representative sample of the device diversity that's out there. If you have the option to release to a subset of beta users, it will probably help to widen the pool of devices and users. Second strategy is experimentation. So one issue with staged rollouts is the bias towards newest and most upgraded devices. Metrics such as latency can look great on newer devices, but then the trend becomes worse over time and you're left wondering what happened. Folks with better networks may also upgrade earlier, which is another example of this bias. Now, these factors make it difficult to accurately measure the effects of a new release. It's not a simple before and after comparison of metrics and may require some manual intervention and interpretation. So a better way to release changes could be to release via experiments and conduct A/B analysis. Now, whenever possible, randomize the control and treatment population within the A/B analysis to ensure that the same group of people are not repeatedly upgrading their apps. And a third strategy could be feature flags. Now, this is another option to manage production changes. The general best practice is to release a new binary with the new code and turn feature flags off by default usually. This gives more control over determining release radius and timelines. Rolling back can be as simple as ramping down the feature flag instead of building an entire new binary and then releasing it again. Now, this is with the assumption that rolling back the flag is not breaking your app, and we have to test for it before we implement it. Now, one quick word of caution in terms of accuracy of metrics is to take into account the effect of upgrade side effects and noise between the control and experiment population. The simple act of upgrading an app can introduce some noise as the app restarts. The one way to address this is to release a placebo binary to the control group. This binary doesn't really do anything, but will also upgrade or restart, thereby giving a more apples to apples comparison of metrics. This is, however, not ideal and has to be done with a lot of caution to avoid negative effects such as battery consumption or network usage. Now, even after doing all of the above and putting all of this governance in place, the power to update their app still lies with the user. This in turn means that as the newer versions keep releasing, older versions will continue to coexist. There can be many reasons that users don't update. Some users disable auto updates, sometimes there's insufficient storage. On the other hand, privacy and security fixes could be strong motivators for upgrades. Sometimes a user is just shown a dialog box and forced to update. Now, as client apps grow and add more features and functionalities, some things may not be doable in the older versions. For example, if you add a new critical metric to your application in version, say 2.0, that metric will only be available in versions 2.0 and up. It may not be sustainable for SRE to support all possible versions of a client, especially when only a small fraction of the user population is on older versions over time. A possible trade-off is developer teams can continue to support older versions and make business or product decisions around supporting timelines in general. Now, we've focused a lot on the client side so far. This slide is a quick reminder that making client changes to an app can still have server-side consequences. Now, your servers may already be scaled to accommodate daily requests, but problems arise when unintended consequences occur. Some examples could be time synchronization requests, or maybe a large global event causing a large number of requests to your server suddenly. Sometimes bugs in new releases can suddenly increase the number of requests and overload your servers. Now we'll see an example of one such outage in the following section, which brings me to case studies. Now in this section, we address the topics covered in the previous section through several concrete examples of client issues that teams have encountered. The slide also notes practical takeaways for each case study, which probably you could apply to applications. Now, this first case study is from 2016, when AGSA, or Android Google Search app, tried to fetch the config of a new doodle from the server, but the doodle did not have its color field set. The code expected the color field to be set, and this in turn resulted in the app crashing. Now, if you see the graph, the font is very small, but it shows crash rate along a time series. The reason the graph looks like that is because doodle launches were happening at midnight for every time zone, resulting in crash rate spikes at regular intervals. So the higher the traffic in the region, the higher the spike. This graph made it easy for the team to correlate issues with the live doodle versus a generic infrastructure change. Now, in terms of fixes, it took a series of steps and a few days to implement an all-round concrete solution. In order to fix the outage, first, the config was fixed and released immediately, but unfortunately, the error still did not go down right away. This was because, to avoid calling server backends, the client code cached the doodle config for a set period before calling the server again for a new configuration. For this particular incident, this meant that the bad config was still on users' devices until the cache expired. Then a second client-side fix was also submitted to prevent the app from crashing in this particular situation. But a similar outage, unfortunately, happened again after a few months. But this time, only older versions without the fix were affected. After this outage recurrence, a third solution in the form of server-side guardrails were also put in place to prevent a bad config from being released in the first place. So in terms of key takeaways, we realize that client-side fixes alone don't fix everything. In particular, there are always old versions in the wild that may never get updated. So whenever possible, it's important to also add a server-side fix to increase coverage and prevent a repeat incident. Also, it's good to know your app's dependencies. It can help to understand what changes external to the app may cause failures. It's good to have clear documentation on client dependencies and server backends as configuration mechanisms. Case study number 2, again AGSA. I think the reason I bring up AGSA case studies is my team, Client Infrastructure SRE, is on call for the search app. So it just gives me more data to play around with. So this case study, this incident happened in 2017. It was one of our largest outages, but still a near miss of a truly disastrous outage, as it did not affect the latest production version. Now, what happened was this outage was triggered by a simple 4-character change to a legacy config that was unfortunately not canaried. It was just tested on a local device, run through automated testing, and then committed to production and then was rolled out. So two unexpected issues occurred. First, due to a build error, the change was picked up by old app versions that could not support it, and then the change was rolled out to a wider population than originally intended. Now, when the change was picked up by the older versions, they started failing right on startup. And once they failed, they would continue to fail by reading the cached config. So even after the config was fixed and rolled out, the app would keep crashing before it could fetch it. So the graph that you see on your screen, it shows daily active users of the AGSA app on the affected version range over a 2-week period leading up to and after the outage. This outage took a while to get resolved. So after scrambling for days, the only recovery we figured out, unfortunately, was manual user actions, requesting users to upgrade via notification, which prolonged the outage and resulted in very bad user experience. So lots of takeaways here. Firstly, anything that causes users to not upgrade is similar to accumulating debt. Older apps are highly susceptible to issues, so the less successful app updates are, the larger the probability of a bigger population getting impacted by a backward incompatible change. The next thing we learned was to always validate before committing or caching a new configuration. Now, configs can be downloaded and successfully parsed, but an app should interpret and exercise the new version before it really becomes the active one. Now, cached configs, especially when read at startup, can make recovery difficult if it's not handled correctly. If an app caches a config, it must also be capable of expiring, refreshing, or discarding that cache without needing the user to step in. Best thing is to not rely on recovery outside of the app. It's ideal, doesn't always happen. Sending notifications has limited utility. Regularly refreshing config and having a crash recovery mechanism is maybe a better solution. But at the same time, similar to backups, crash recovery mechanism is valid only if it's been tested. So when an application exercises crash recovery, it's still a warning sign. It can conceal real problems. What if your application would have failed if not for the crash recovery? You're again in an unsafe condition because the crash recovery is the only thing preventing failure. So it's good to also monitor your crash recovery rates and then treat high rates of recoveries as problems in their own right. This last case study demonstrates how apps sometimes do things in response to inorganic phenomena, and capacity planning can go for a complete toss if proper throttling mechanisms are not in place. So this graph that you see on your screen is a picture of the rate at which certain mobile applications were registering to receive messages through Firebase Cloud Messaging. This registration is usually done in the background, that is, if users install apps for the first time or when tokens need to be refreshed. This is usually a gentle curve which organically follows the world's waking population. Now, what we noticed here one day were two spikes followed by plateaus. The first plateau went back to normal, but the second spike and the plateau that looks like the teeth of a comb are representing the app repeatedly exhausting its quota and then trying again and again and again. So the root cause was identified as the rollout of a new version of Google Play services, and the new app version kept making these FCM registration calls. The teeth of the comb that you see are from the app repeatedly exhausting its quota and being repeatedly topped off. Now, FCM thankfully was working fine for other apps because of the per app throttling mechanism in place, and the overall service availability wasn't at risk. But this is an example of the consequences of scale in mobile. Our devices have limited computing power, but there are billions of them. And when they accidentally do things in unison, it can go downhill really fast. So key takeaway, most importantly, was avoid upgrade proportional load. In terms of release management and uptake rates for installation, we created a new principle for ourselves. Mobile apps must not make service calls during upgrade time, and releases must prove via release regression metrics that they haven't introduced new service calls just as a result of the upgrade. If new service calls are being deliberately introduced, they must be enabled via an independent ramp up of an experiment and not the binary release. In terms of scale, a developer writing and testing their code, a one-time service call feels like nothing. However, two things can change that. First, when the app has a very large install base, and second, when the service is scaled for the steady state demand of your app. Now, over time, capacity management can optimize for a footprint that's close to the app's steady state needs, so avoiding upgrade proportional load is valuable at large and small scale. Now, this brings us to the last slide of this deck. To quickly summarize this talk, a modern product stack is only reliable and supportable if it's engineered for reliable operation, all the way from the server backends to the app's user interface. Mobile environments are very different from server environments and also browser-based clients, presenting a unique set of behaviors, failure modes, and management challenges. Engineering reliability into our mobile application is as crucial as building reliable servers. Users perceive the reliability of our products based on the totality of the system, and their mobile device is their most tangible experience of that service. So key takeaways: design mobile applications to be resilient to unexpected inputs, to recover from management errors, and to roll out changes in a controlled, metric-driven way. Monitor the app in production by measuring critical user interactions and other key health metrics. It could be responsiveness, crashes, data freshness, etc. Design your success criteria to relate directly to the expectations of your users as they move through your app's critical journeys. Then release changes carefully via feature flags, if possible, so that they can be evaluated using experiments and rolled back independently of the binary releases. Understand and prepare for the app's impact on servers, including preventing known bad behaviors. For example, the thundering herd problem we looked at. Establish development and release practices that avoid problematic feedback patterns between apps and services. It's also great to proactively create playbooks and have incident management processes in anticipation of client-side outages as well, and the impact it might have on your servers. And that's the end of this talk. Thank you.
Hi, Pranjal. Great talk. I really enjoyed it. So congrats. Learned a lot. Actually, I was thinking how could I map this with my reality? Since we don't have a mobile application, we have distributed software to our clients that they really need to install. And actually, some things map. Obviously, not everything, but some things map. But one question that arises from what you said is that in terms of mobile application, we need to really make sure that we are adding value to each release and not just, well, release every feature as frequently as normal DevOps world in server side. Where do you cross the line between, well, multiple releases a day versus, well, a single release 3 times a year, something like that? So where do you cross the bridge?
Now, that's a good question because I've seen different teams do this different ways. So I think I would preface my answer by saying there's not one answer to this because I've seen release cadences that are maybe quarterly and sometimes that are daily, right? So I think it all depends on metrics. If you're monitoring what it looks like as the cost of upgrading to your user versus their happiness. So let's say if releasing too many features, but at not a big cost to the user, that's a good thing, like they're making it happy, right? But if you're releasing slowly, it might be acceptable for the users to release slowly and still not abuse their mobile device, let's call it that way. They still could be okay. I think it's best to look at metrics and maybe gather some user feedback because there's not one answer because there's a lot of juggling that has to go on, like product decisions versus business decisions, user happiness, reliability. So it's a mixed bag. Sorry, I don't have a concrete answer to that question.
I have a question too. As Sergio said, I think it was a really good talk, and it's almost like a checklist for teams that need help or people want to understand more what SRE for mobile means, what its implications. So my question is more from an organizational perspective. How do you organize at Google? Do you have, because like you said, mobile kind of challenges can be very different from the server side, or the client side can be very different. Do you kind of organize like that you have SRE teams or people who are focused on the client side, others on the server side, or do you try that everyone who is an SRE has kind of a broader picture of what can go on both on client and server?
Right. So I think that's a very good question, because this is something that we are always thinking about. Like, we have a limited number of people and different responsibilities in every org, right? So the way I think we operate right now is certain apps that are extremely important for the users could potentially have SRE expertise, like our team is one of them, right? Then certain infrastructure components, which say maybe 50 or 100 apps are using. So let's say there's a change management system that a lot of teams in the company use. There could be a dedicated team that maintains that system. And sometimes teams that work on the server side could have some side projects. They may not be dedicated for client-side reliability, but at least understand the to and fro between, or the cost and impact of both these changes. So that could be one model to operate. A fourth model to operate is something that I've been working on, is develop tools so that all of the client side and server side monitoring, or all these aspects that I talked about, so results of change management, monitoring, logging, if you could correlate those changes and have them visually present at one place. So think of it as a horizontal project that multiple teams can use. They could be server-side SREs, client-side SREs. This is another model to work on. So that's something I work on in my day-to-day. I would actually like to add something to the answer to Manuel's question. So another thing you could think of, something as my team does, is let's say there is a big outage that happened on the client side, right? The server side team responsible for server side reliability, but they did have a client side outage. Our team would probably go and consult with them, and we see what the problem was, why the failure happened, and we would try our best to integrate solutions to at least mitigate that incident in the solutions that we roll out and that team could use.
It actually leads me to another question. Where do you normally start with kind of the diagnosing of an issue? I don't know, I'm guessing you get kind of report from the mobile app, and then you go and see where exactly in the workflow where exactly is the problem, or what is the most common situation for you to start diagnosing a problem with let's say a critical mobile app?
Right. So this could start potentially in two ways. So I'm not on the on-call SRE role, but I can talk a little bit about what I know. So either it could be, or three ways now I can think of. So the first most critical problem would be, let's say if there is an outage we don't know of, but users are experiencing. Let's say our monitoring is not good and users are experiencing, and it shows up in the form of Twitter outage, or like a Twitter outrage, or where people are complaining online, but we don't know about it. That would be a big deal. That would be failure mode number one. Another thing could be, let's say if people, you can send bug reports, right? So you can send a screenshot, you can send error reports. If that cluster suddenly starts alerting us that a specific set of circumstances, maybe like this locale, that version, these many users, that set of circumstances, that would probably maybe warrant an investigation. Or either of those two doesn't happen, but maybe our internal monitoring is picking up something that the external audience has not yet realized, that would warrant an investigation. And the first thing we could do is probably check is if there's currently an experiment being run or a new release that has gone out, and try to correlate those changes based on the monitoring we have.
First, thanks for the talk. I must confess I didn't saw all the talk, but I did read your book or the book that you write with your colleagues a few months ago, and it was for me very insightful. I've been exploring this perspective, this world of monitoring and observability, and so it's very useful on this. But something that at least I've been struggling is, and I work in a company that has several customers, and we sell to them a product where they can build mobile applications, and then we want to pursue. We want to persuade the customers to put in place a good approach like these ones that you have been explaining. So my question is, did you felt eventually in Google or other organizations also the struggle of those that will benefit for doing this approach of doing so, and how did you overcome it?
Right. Now, I think that's a very good question. Again, something that we struggle with on a constant basis. I think the biggest problem that results in the situation that you described is, I think it boils down to priorities, right? And the biggest problem with people who work on the reliability side of things is until a problem happens, nobody realizes how important it is to put guardrails in place so that the problem doesn't happen, right? If everything's going smooth and fine, I think product decisions, business decisions sometimes take priority over reliability decisions. That's just something we deal with. One way to maybe help this situation is, I've tried to in the past bring up instances and make it more data driven. So let's say you're trying to make a case for, let's do XYZ. Have there been outages in the past that you can point to and say, this happened, it cost me this much. This happened, it cost me this much. And over time, it has resulted in a big problem. And the way the code is written right now, it could potentially maybe forecast, like it could result in a problem of this massive scale. That's one way to make a case for it, but it is a very, very hard problem to convince even internal clients to take solutions seriously when there's not a problem and it may or may not happen in the future.
I would like to know if you have any funny story, and so something that went wrong, but with a happy ending.
I have to think more about it. But yeah, I can't think of something right now, but if you give me your contact, I'll think of it and reach back to you.
How empowered is an SRE? So do you have what it takes to say no for a given release? For instance, we have already too many versions out there. The clients are not pushing, are not upgrading the solution. We won't release this issue. You have that power to go to a CEO and say, no, we won't do it. That breaks our philosophy.
I think I don't know if we can go to Sundar, but we can definitely no. But this is again a real concern, real problem. We have outages because of this. And if you make a good case and present it properly, again with metrics pointed to past outages, what could happen in the future, like show some real user impact and make a good case for it, yes, absolutely, we are empowered to present it to the leadership, and then they can help us make the right decisions. Yeah.
Oh, so it's the leadership that takes the decision, not you. So you present the case, and it's about the leadership too.
Yeah, I think because each department, like I personally don't have a lot of visibility into the business and product side of why these versions are out there. Maybe there's a reason, maybe we don't see it, but there's a reason. So, but if continuously, if we can show them that there's a problem with this version, I've seen versions being sunsetted because of reasons being presented properly.
Yeah. After I asked the question, I muted myself, and then I could not unmute again.
Yeah.
But yeah, because I was asking this because usually we learned by making errors, of course, but the most the ones that we remember mostly are either the big mistakes or the funny mistakes, because something stupid that something did, but and also the big mistakes that went well in the end. And that's why I was asking that question.
Yeah, no, I think it's a very good question. But if I don't remember it, I'll probably ask one of my colleagues and maybe I'll get them to describe it to you.
And usually there's some story.
Yeah, yeah. Especially with people who've been in the company much longer than I have, like they've seen a lot of incidents, and I'm sure some of them were really funny. Yeah.
What about the conferences that are going to happen soon? Any comments to what's the expectations with these virtual conferences?
I participate in some online conferences, and I think the ones that now are providing a bit more value is when you can engage with the speakers. Usually they have a Slack channel. And one of them, so DevOps Enterprise, actually, we record the sessions, and during the session, if you're a speaker, then you are actually in the Slack discussing, getting questions from people. So I think that works well, but it's obviously everyone is a bit overloaded with screens and Zoom and etc. So I think we'll see. There's currently different companies are trying out different models for these online conferences, and probably some of them will work and stay, and others will fail. But the ones that are just converting physical conferences to online, just like that, I think will be difficult to keep the attention of people.
Yeah, I agree.
Oh, I thought of something that I could answer to Tiago's question.
Go for it.
Oh my God. And this is not like this was from my first job. This is not from Google, but I can try to describe that incident. In retrospect, it's very funny, but it wasn't very funny when it happened, right? So let me try to describe it. So I was working at a company and they were running disaster recovery software. And I think I was a new grad, just entered the job market, and I was given the task of testing the devices that they had on hand based on the portal, the UI that I was given with to test with. So I actually should have asked more questions about what I'm doing. I honestly went ahead and just messed up certain disaster recovery planning of certain people that in the production environment. Now, what I was thinking was the sandbox environment was actually the production environment. It was totally my fault for not asking the right questions. But that was a big outage that happened in the company. And I wasn't even aware that I did something like that. I mean, late at night, my manager called me and was telling me the impact of the mistake that I had made. But yeah, in retrospect, I think it's funny. But I think since we had backups, the recovery was fine. It took a little bit of time, but of course, client relationships were a little sour because of what I did. But I don't know if that's funny for you, but for me, it's very funny.
I have something now. Thank you. Yeah, that's funny. I was thinking about a thing that I did myself. Yeah, I would like to share it with you because it's probably funnier to other people than it was for me. But I was responsible for managing database backup scripts and workflow, and I did something that was that only occurred sometime some months after I was changing things and changing the script. So in the end, the database was sent to the backup server, not copied, but moved. And so it was very funny, not for me because everything was down for a couple of hours, but in the end it worked. And the backup recovery scripts were well done. So in the end, it was okay.
Yeah, quite similar.
It's a common story for lots of us, I would say. The only problem is when we have a story that they didn't have backwards. I don't have that story to tell. But it does happen. And thank you, Pranjal, once again for your time and for the amazing, and for everyone who showed up and that's coming back from vacations and all that, and back to routines. And stay safe, all of you, and hope to see you all soon.